Greetings, welcome back to the channel. Thank you for tuning in today. In today's video, we're going to be looking at aircraft engine fundamentals. We look at what's the purpose of an aircraft engine, how is this purpose achieved, and what's needed for this purpose to be achieved. So welcome and enjoy the video. An aircraft engine's main purpose is to generate the thrust that is needed to propel the aircraft. This thrust is generated in the same way in almost all types of engines. This is through the change of momentum of a mass of air. The operation of an aircraft engine is based on Newton's third law of motion. This law states that to every action there is an equal and opposite reaction. As we move forward, we're going to see how this law is applied in thrust production. There are two basic ways in which thrust is produced on an aircraft engine. One through aerodynamic action, and second through jet reaction. Aerodynamic action is used on those aircrafts that are fitted with a propeller. For example, the aircrafts that are powered by a piston engine or by a turbo-propeller. By rotating a propeller, which is essentially an aerofoil, lift is generated, which acts along the horizontal plane by accelerating a large mass of air rearwards through a small increase in velocity. Thrust is produced. A second method of thrust production is jet reaction. For jet reaction, a mass of air is heated inside the aircraft engine and expelled rearwards at a very high velocity for thrust production. According to what we've mentioned, basing on Newton's third law of motion that states to every action there is an equal and opposite reaction that we've mentioned, we can see from the two ways that we've mentioned thrust is generated, we see that there must be an action, and in the two cases that we've mentioned, the action is the acceleration of a mass of air rearwards. This is the action that takes place, and the reaction that we get is the thrust that is produced, which propels the aircraft forward. To every action, which is the acceleration of a mass of air rearwards, the reaction is the thrust being produced in the opposite direction, which propels the aircraft forward. In this picture here, we see two aircrafts. One uses the aerodynamic action, and another one uses the jet reaction in thrust production. One accelerates a large mass of air rearwards through a small change in velocity, and the other one accelerates a small mass of air through a high increase in velocity in order to generate thrust. Two things are needed in order to generate thrust. Number one is air, and number two is acceleration. In order to generate thrust, a mass of air has to be accelerated rearwards by an aircraft engine in order to generate thrust in the opposite direction. Generation of thrust or thrust production is based on Newton's second law of motion. This law states that the rate of acceleration of a body is directly proportional to the force applied and acts in the direction of the force applied. By this definition, we can generate this formula here. Force is equal to mass times acceleration. I will use the following example to illustrate this second law of motion and how it applies on thrust production on an aircraft. We can have two different aircrafts. We can have one turbo-propeller aircraft and one turbojet engine. On a turbo-propeller aircraft, we see a mass of 385 is being accelerated rearward. And we see the acceleration being imparted on this mass of aircraft is 70 meters per second squared. If you multiply these two values, you get a force of 26,950 Newton. This is the force or the thrust being produced by this turbo-propeller powered aircraft. On the second part, we have a turbojet engine accelerating a mass of air of 55 kilograms, and the rate of acceleration is 490 meters per second. If you multiply these two values, you'll get a force of 26,950 Newton being produced by the engine. This is the thrust being produced by the engine. In these two scenarios you've seen here, we see the same amount of thrust being produced by two different types of aircraft engines, because these two aircraft engines are using different masses of air and are imparting a different rate of acceleration on the mass of air. Finally, we want to look how combustion is achieved on an aircraft's engine. And for this example, we use a gas turbine engine and a piston engine in order to compare how combustion is achieved in both types of engine. In this picture here, we see how combustion is achieved and the events that leads up to combustion in an aircraft engine. In the top picture, there's a representation of a gas turbine engine, and then the bottom part, there's a representation of a piston engine. I want to point out one thing. In a gas turbine engine, the events and the processes that takes place inside the aircraft engine during combustion are continuous events, while in a piston engine, these events are intermittent. In a gas turbine engine, these events take place at the same time in different locations. In a piston engine, these events take place in the same location, which is in the cylinder, but at different times. So this is a major difference between a gas turbine engine and a piston engine. For this reason, combustion in a piston engine is said is intermittent, while combustion in a gas turbine engine it is said to be continuous. This difference in the combustion or between a gas turbine engine and a piston engine is the one that brings about the vibration that is high in a piston engined aircraft. On a gas turbine engine, the process starts by air flowing through the intake through the engine. From the intake, it goes through the compressor where it is compressed. From the compressor, compressed air goes through the combustion chamber where fuel and heat is added. From the combustion chamber, the air goes through the turbine where the energy to drive the compressor is derived. Then from there, the air is expelled rearwards through the exhaust of the engine, generating thrust. On a piston engine, we have 4 strokes that takes place to complete a cycle. One, there's an intake stroke where fuel and air is allowed to flow into the cylinder. Then after the intake stroke, which is represented by this first portion here, the second stroke is the compression stroke. As the piston starts to travel from bottom to the top, the fuel air inside the cylinder is compressed, and as the piston nears the top dead center, this fuel air is ignited, and due to the increasing pressure in the cylinder, the piston is pushed downwards, and this is what is known as the power stroke. This push is transmitted, this power, this force is transmitted through the piston rod, through the crankshaft, and this is the power that is needed to rotate the crankshaft, which in turn rotates the propeller of the aircraft through a reduction gearbox or through a gearbox. Finally, we have this last stroke, which starts by the piston traveling from the bottom dead center to the top dead center, and the exhaust valve is opened. And as the piston turns, or as the piston moves from the bottom dead center to the top dead center, the gases inside the cylinders are pushed outwards of the cylinder. And then the cycle starts again from the first stroke, the intake stroke, to the exhaust stroke. So this is what we had for you in this video today. We look forward to see you in our next video where we will discuss further fundamentals of an aircraft engine and also the various principles that these engines used in order to operate. Thank you for watching this video till the end. We value your time, and I hope you'll share this video with your friends. And if you haven't subscribed to the channel, we kindly request you to subscribe to the channel and also turn on the notifications so that you'll be notified every time we post a new video. I'll see you in our next video.